Hello, trigonometry. Okay, so sine of 30 should be 0.5. If you at all have some issues at the beginning with the calculator, Mark, do you mind turning off the lights for me, please and thank you? If you have issues with your calculator, I will help you figure it out. But I would say this is probably the main reason why you want your own calculator. This is it, trig, right? Because trig, if you get some other calculator you're not used to, you're not gonna, it might have some little nuances that throw you off. Your whole answer is off and it's frustrating, okay? So this is why, one of the main reasons I would say get your own, okay? All right, so let's keep going here. Trigonometry. So I tell you, right, stop, make sure your calculator is set to degrees. You either go to mode or you go press the DRG button. Some of you, if you just keep pressing that, I don't like calculators with that DRG button because it presses onto other buttons when you put it in your backpack, whatever, and it changes on its own. So you got to watch out. If you have one of those, just watch out for that, right? Make sure it's set to what it's supposed to be. Okay, page 2. A lot of review stuff, okay? A lot of review. So here we go. Isosceles, equilateral, right triangle. The three main types that you will encounter. Isosceles, I will put it up here. Two angles that are congruent. Okay? And two sides that are congruent. I hope you can see that. What is that symbol I'm using? That's called congruent, right? So if you, let me put that up here. This symbol, it's an equal sign with a third wave using COVID wording. Second, third, fourth wave, right? Congruent. Not funny, Mr. Dirksen. I know, it's probably not funny. Maybe let's not talk about it. It was a tough time for everybody, especially for you guys. So isosceles triangle, that's what's true about them. You could have them in variation, right? But this is the main, like usually when you think of an isosceles triangle, we know that these two sides are congruent. That's the marking. And so the angles across from them, the angles across those two sides will also be equal. There's a relationship between the angle and the side, okay? If the sides are the same, the angles will be the same across from them, okay? And so keep that in mind. This branches off into two main categories, okay? So let's see how we do with room here. So you could have a scenario, draw another isosceles triangle. And let's say you get something like this, and then there's only one angle provided right there. That's 100 degrees. I hope you can see that. The red is 100, okay? It's a bit small. With an isosceles triangle, if you know one angle, you know them all. Did you know that? Because this angle is the same as this angle here. I'm going to call it x. Okay? So angle x is going to be 180 degrees minus the 100, and that is going to be split in half. That is 180 minus 100 is 80. 80 degrees in half, right? So angle x is 40 degrees. You right now found all angles, right? You found the two 40s and the one that is 100, okay? Branch off, it's okay if we use a bit of space of the equilateral. So this could be one scenario. The other scenario is, and I'm getting you ready for the other unit, which is geometry after this. Let's say you're told, hey, this is an isosceles again. Let's see here. I'm going to say that this 50, let's say they give you that that's 50 right there in that corner. That's it. Find all the angles. Well, you actually know them all, because if this is 50 across from that side, we also know that the other side that is congruent will have the same angle across from it. So to find, let's call this y. So to find angle y, we're just going to go 180 minus 2 times 50. 2 times 50 is 100, right? So it's really 180 minus 100. You get that 80-degree angle there. So isosceles triangles are good because you can easily find the rest. Okay, so I'm going to kind of tell you to do this, right? This is all part of isosceles triangle. My bad. I messed up. I should have left more room. So the idea is only one angle needed to find them all. Okay, that's the cool thing about an isosceles triangle. Equilateral, 3 angles that are congruent, 3 sides that are congruent. That's important to note, right? It's because all sides are the same that all angles will be equal, and vice versa. Okay, so we can do one of these. And I think everybody knows if you split 180 exactly into thirds, right, what do you get? 60 degrees in every corner. Doesn't matter how big or how small that equilateral triangle is, there will be guaranteed a 60 inside the interior angles every single time. Block that off. And here we talk about right triangles. I will make a right triangle way up here because I'm going to need that space underneath. Way up here in the corner. What do you always call the side across the 90? Hypotenuse, right? Hippopotamus. I don't know. Hypotenuse there. So this one is leg and this one is the other leg. That's what I want you to know, right? The two sides that meet at a 90 are called legs, really. So some teachers might have said, no, this is A, B, and C is your hypotenuse. I don't use letters because it often throws us off. So if you want to know what the hypotenuse is, so let's say you know both legs, you'll use this one. Hypotenuse is equal to the square root of leg squared plus leg squared. That's it. That's all you do. You add the squares of the legs and then you square root it when you're done. Can I use ABC, Mr. Erickson? Yeah, you can if that's what you prefer. Sure. If you want to know one of the missing legs, so they give you the hypotenuse and one of the legs, right? You take the square root of hypotenuse squared minus leg squared. That's as simple as that. Those are the two formulas that I use when I need to. When there's a right triangle, I will use them from time to time. No. And then you just, yeah. So that's actually true. What Victor is saying is that, should I do that at the very top? The hypotenuse squared is equal to leg squared plus leg squared. That is true. That is where I'm getting these two formulas from. Yeah, this is just a shortcut. So a lot of this is going to be review, guys, but I will teach you something probably brand new for most of you. Not the trick you've learned in grade 11 or 10. Let's keep going. Sum of interior angles is always 180. That's not a surprise, but So it doesn't matter what the triangle looks like. Just try your best to draw them. Doesn't matter. That's a 90 there. But we know that A, B, and C, it doesn't really matter. Right? A plus B plus C is always equal to 180. It doesn't matter what the triangle looks like. That is true. And really, to summarize, if you know two angles, you know them all. If you know two angles, you know them all. If it's isosceles, you only need one angle, you know them all. If it's equilateral, you know them all every time, right? So, but if you know two angles, you know them all. Okay. Next, supplementary angles, and watch this. Somewhere along, like somewhere in the middle here, I'm going to use that space for complementary angles. What do supplementary angles add up to? Anybody brave enough to? Supplementary angles? They add up to 180 or 90? Which one is which? Well, this one would say add up to 180. Complementary add up to 90 degrees. And I will give you a little cheesy phrase to remember. It's right, that's a 90, to complement. It's right to complement someone, right? So complementary angles are 90. I don't know. It's a cheesy little phrase that perhaps will help you out. So watch this for supplementary angles. The idea is that you always want to identify a straight line. And if you pick any point along that straight line and make a point like that, you're actually creating two different lines. And the angle from this line all the way to the other one is 180. Okay? So if I were to come and cut this, right, introduce another segment like that, and if somebody tells me, hey, this is 30, then automatically you'll be thinking this is 150, right? They add up to 180. So these are supplementary. Right next to it, how is this going to be helpful in this unit? It's going to be helpful because you will sometimes encounter something like this. There's a triangle, and I give you the angle outside here that is 120. You need an angle inside the triangle, right? So if this is 120 here, right, then this must be 60. Right? Voila, now you have an angle inside the triangle. I want you to highlight, if you have one, the fact that it's always happening along that straight angle, along the straight line. Complementary angles, that would be something like this. If you have, make a dashed vertical and a solid horizontal. We know that the vertical and the horizontal, they meet at a 90. And so sometimes do you remember angles of depression? I'm sure you've heard of angle of depression. So that is usually here, stated here. So if this is 40, right? If this is 40 and you know that these two lines make a 90, then of course it follows that this would have to be 50. They add up to 90. So these two would be considered complementary. I'll talk about angle depression later on. Okay, let's see if you remember this part. Okay, there is for angles. Can you write this down? For angles, we use a 3-letter notation, and for sides, we use 2-letter notation often, not always. Okay. But I allow you to use other letters once. If you don't like the 3-letter notation, you just need to make that happen. You can use theta. Anybody heard of this, of theta before? This one, right? Greek letter, theta. You can use that, but I will use this. I will call angle ABC, I'll call that X. CBD, I'll call that Y, Z, and K. So go ahead and do that. Call them X, Y, Z, K on the side here. Now pay close attention because you're going to have to work. I'm going to find one and you're going to find the other three. Okay, so angle ABC, angle ABC. Just read it the way it is there. A, you start there. Then you go to B, and then you go to C. So if you connected these 3 lines, forget about everything else. The angle would be formed right here. B is the middle point, right? And so that we will put an X there. That angle would be referred to as X. I want you to put a Y, a Z, and a K in this diagram. I'll do the attendance in the meantime. You get a minute and a half maybe to do that. So figure out, it doesn't matter if you make an effort, okay, to change that. Angle CBD. C, B, D, right? So you're connecting C with B and then D. So it's this one here. That gets a Y. X and Y are supplementary, right? At the same time. Let's find CDE. CDE, right? So you're connecting CD to E. So that's Z right there. And then we have BDC. So if you were to make that connection, that is right there, K. You are free to do that on a test, on a quiz. If you want to rename something, just make sure this is clearly stated somewhere that you are doing that, okay? And then you're fine. What about line segments? So we're going to go 1, 2, 3 with this. This I'm pretty sure you're familiar with. Segment BC. So BC is right here. That's the first one. We're going to put a 1 there. DB. So going from D to B, that'd be right here, 2. And this would be 3 out here. Segment DC. So now we know how to do. Don't use numbers if you want to rename it, right? But I didn't want to mix up too many letters here. So there you have it. Keep going. So you just have to train your book a little bit. Bend that corner. Okay. Okay, we use caps for angles and lowercase for sides across from the angle. Very important. So if you draw one, most likely, listen carefully, most likely you will not have a right triangle. Most likely. SOHCAHTOA, if that means anything to you, don't worry about it. Throw it out the window, okay? We're going to learn different trig. So most of our triangles are going to look like this. So it doesn't matter where you start if you have to sketch it. If you, for example, say, hey, triangle ABC, most teachers will go clockwise. right? They'll start with A here and like that, which means that across angle B, you'll have lowercase c talking about this side. Across from capital C, we have lowercase c, so that's the side C. And across from uppercase A, we have lowercase a like that. That's how you label it. Okay. If you have an obtuse one right next to it, we can go DEF. DEF if you want. So this would be lowercase d, lowercase e, lowercase f. Okay, so that's how we label in this class. Yes, you can call side E. Watch up on the screen. Side E can also be referred to as side DF. It's the same thing. Okay, so we can use one or the other. It's like saying $5 or $5, right? Like we all know it's the same thing. Right? This one right here would be triangle ABC, and this one right here would be called triangle DEF. So can I call it triangle Fed? Sure. You can go the other way, right? So that's all good. Still review, by the way, this is still review. But that's all right. I think you can handle some review. Angle of elevation and depression. This is important. So I'm going to try my best here. I'm going to make it easy for you, right? That way you don't know that I'm not good at art, right? So I'm just going to say, hey, pretend this is a person there and a dashed horizontal line coming straight out of the eyes, right? Some superpower there. If you're seeing something on the ground, right, a spider or something that's crawling on the ground, in this case, you'd be looking down to it, right? Straight down to it. That's your line of sight. And so the angle that's formed between the horizontal, let's write this down nice and capital here. Horizontal. Okay, that is important. It's always with respect to the horizontal. This angle right here would be the angle of depression. And on ACs and stuff, I will ask you that. It's like, hey, is this the angle of depression? And you're going to have to know where it should be going. If you're looking at something that's high up in the air, a plane, a kite, a bird, then you're looking up. Okay? And so this angle formed here is the angle of elevation. That one, most of us can wrap our heads around that one. Okay? If you have a highlighter, I will make sure that this horizontal is very clearly seen, right? I will make a note here. Always with respect to the horizontal. Always with respect to the horizontal. Okay. I will give an example of what not to do. Angle of depression. So let's say, hey, the angle of depression is, let's say the angle of depression is 30 degrees. Draw a triangle with it. I'll tell you which one is going to be wrong. Or let's make two. Put the 30 here. Let's make another one. Put the 30 there. Which one is correct? Not this one. There's no horizontal there. There's a horizontal there, right? See it? This one? So you can bring an angle in. What would the angle be in here? It would be 60, right? Because we know that there's a 90 formed here. So yes, it's 60, but this is wrong. So you go X here, you go check mark there. Okay. So this is a little aside for you to make sure you don't mess up on that. Okay. Oh, hey, you like highlighting? Me too. There we go. It brings life to your notes, guys, if you highlight. It's like Five Alive, that commercial, right? Brings it alive. Okay. Keywords. Maybe just key concepts. I hope you know your north and south, east and west. Because if you don't, you're not alone. Okay. North, south, east, west. Okay. So this should say we, not you. Okay. Some of you memorized it with the, what is it? Never eat soggy wieners or something like that. Something whatever your teacher chose to use it. Okay. So for example, a tree is 5 meters due west. Oh, sorry, east. I meant to say east. If a tree is 5 meters due east of you, then you should understand that the tree is east, right? This is east of you, to the right of you. And there would be a 5 meter distance, right? 5 meters here. Boom. Obviously, they'd have to give you an angle. All of that would have to apply there. Another concept here, speed. No, I will do this. Watch. This is much better. Distance is time multiplied by speed. Can you write that down? That is probably worth adding to your study sheet. Page 3. Example, a plane travels at 310 kilometers an hour for 2 hours. It's like, what? Speed and time? I need a length for that triangle, right? I need a length for one of the sides. No problem. Distance is going to be 2 hours times 310. And that's 620 kilometers. Could be miles, could be whatever. So that is important, actually. It doesn't show up very often, but it does show up from time to time. That one right there is how you deal with speed, if speed is given. Now we're ready, finally, to learn something new. Maybe some of this was new to you. If you need to, yeah. Okay. Let's go over to page 4. The sine law. Okay, I'll give you a little heads up. We're going to study sine law and then cosine law. Maybe some of you have heard of it already, but unlikely. So first I'm going to park today just sine law, and then tomorrow I will introduce cosine law. I'll tell you this, once you know how to use both of them, you can solve any problem, any triangle out there. You can solve it. You don't need SOHCAHTOA. You don't need any of that. Okay. So follow me here. Sine law. Too excited. The sine law. In previous years of math, you've learned how to solve for missing angles and sides of right angled triangles. But what about triangles that are not right triangled? We actually have a name for it. In order to solve triangles that are not right angled, it's the name we have for anything that isn't a right triangle is called oblique. Okay, that's an oblique triangle. We need some new tools. The first new tool that we will examine is sine law. Okay, sine law it states this. This is almost like your Pythagorean theorem. Okay, not in the sense that it works the same way, but we state what it's claiming, and this is what it's claiming. Watch here. This is also on your formula sheet, so you don't even need to have this on your study sheet. Sine law, the back of the formula sheet has it. Okay. So sine of angle D, right? This is angle D right here, over side D is going to be exactly the same as sine of E over side E, and so forth. Angle F over side F. So if you have highlighters, I'm going to actually make this very obvious here. Right? These are paired up like that, and you have them paired up like that here as well. Okay. And you have D and D is right there. They're paired up right there. And I have orange. That is paired up right there. Okay, so you see that sine law is claiming that if you were to divide those two, you would have the same number all across. Okay, this would be the same as that, which would be the same as that, and so forth. And it works with the following scenarios. So I'm just going to give you some scenarios where you know for sure. Why does it say triangle XYZ? What happened? Let's call it DEF, okay? It's actually triangle DEF, not XYZ. Make sure that's accurate. So let's see here. When would it work? The first scenario is, let's pick any angle. I'm going to pick this one. If you know the side that's across from it, and any other side, it doesn't matter. Let's say this side. This is what we call a side-side angle. And I'm not going to tell you what it spells backwards because it doesn't matter. But I can't say it on YouTube, right? But SSA is what I call it. If you didn't get it, that's fine. Let's say you know this angle, a side across from it, so and any other angle. That's what we call an angle side. Not very important for you to remember these guys. Okay, not very important. I don't care if you remember that or not. And this one here, let's say you know two angles and the side that connects those two angles. This is what we call an angle side angle, and this is a special case, right? It turns out that if you know two angles, right? So right on top here, we know 2 out of 3 angles, okay? So we find the third. This one right here, okay? So technically now it goes check mark, okay? And this is what I want you to remember out of this, okay? You ready? There's a pair here. You know the angle and the side across from it. Perfect. You know the angle and the side across from it. Here, at the beginning, you didn't know, but it was easily, the third angle was easily determined. So you also have that pair there. Okay, pay attention, guys. So this is what I call the hidden pair. Hidden pair. So it's the couple that hasn't announced it yet. They're not holding hands in the hallways yet, right? They're like, where now? So it's a hidden pair. So that one is easily found, right? If you have two, you can find a third, and you're good to go. So what do I want you to remember out of this whole, whatever I did here, is this one down here. If you have a side angle pair, we use sine law, just as simple as that. Because remember, later you're going to know cosine law. So you're going to have to distinguish which one should I use. If you have a pair, use sine law. Simple as that. It works every time. So come with me and let's put it to the test. Let's use the sine law to solve. And you'll actually be working right after this example. So we're going to use sine law to find the side length. Okay. Page 5. Watch this. I have a pair. I have a pair. Therefore, I'm going to use sine law. That's the first thing that I'm going to identify here. And these little boxes here, I put them down after I work through these booklets. So if you're given two angles, go ahead and find a third angle. We're using sum of triangles 180. And then note, sine law also works on right triangles. Notice that, right? Right triangles work as well. So watch this. You take sine of 52 degrees over, you divide it by the side that's across from it, which is 16.8 centimeters. Then you say that is equal to another pair. We're going to find another pair, but we don't quite know everything about it. We know this angle, which is across the side that we're trying to solve, which is perfect. So A goes here, and at the top we go sine of 72 degrees. That's your setup. Okay. And now what does this look like? Cross multiply and divide, right? So you might just, let me pause here for 1 second. You might think like, why do we have three things here if all you're doing is two? Well, this is saying this is true, but you only ever want to use two pairs at a time, okay? Not all three. So here we go. To find A, we just cross multiply like this, and we divide going up, just like before. So this is the step a lot of you skip. I don't want you to skip it. So side A is going to be 16.8 times sine of 72. You're like, Mr. Dirksen, why aren't you going sine of 72 times that? Because sometimes our calculators multiply these two first before finding sine. So I just kind of swap it, but they're multiplying nonetheless. And then we divide by sine of 52. And here is where you need to use your calculator, okay? Make sure you know how to use it. You go 16.8 times sine of 72. I hit equals at that point. Divided by sine of 52 degrees. And I get 20.28. 20.28 if you round it, right? And we are in centimeters. So you just found side A just like that. You could not have solved this using SOHCAHTOA because you don't have a right triangle. Sine, cosine, and tan, I should say. Some of you did not use SOHCAHTOA. So how about we do this right now? You take a pen or something, and you just say that this side you just solved is that. Okay. So you have another pair now. A known pair is there. However, I don't like to use it because it could be wrong. You could have made a mistake. So what is it asking for us to do next? Calculate the length of side C. Side C is there. We don't know what that angle is. So as it stands, we can't. But we can easily find angle C, right? Because we know 2 angles out of the 3. So let's do this. Need angle C. And that is found by going 180 minus 52 minus 72. Angle C is 56. 56 degrees. That's not the answer. That's angle C, but I need it. I need it. And watch what I'm going to start with again, guys. You know that pair that I knew right from the beginning? That's the one I'm going to use again. Okay, that's the one I'm going to be using again. And on the other side, if you want side C here, you need sine of angle C here. Okay, so this angle got plugged in there because they go together. Angle C goes with side C. And you do the same thing again. Cross multiply and divide. So 16.8 times sine of 56 divided by sine of 52. So let's do this one more time here. Hopefully you get to use this correctly. So I multiply, then I divide, and that's 1767. 1767 centimeters. Boom. If you highlighted the pair up there, on that triangle way up there, see how I highlighted that across? I kind of want you to do the same here. Like you use that same pair for both answers. Okay? Use the same pair to figure out both of the missing sides. But you have to do an extra step here, right? Find angle C and then determine side C. We're almost done. And then now you're going to try it, but I want to emphasize one more thing. Write down angles A, angles B, and angle C like this. And then right next to them across, we're going to have all the sides lined up. I want to emphasize one point. Angle A is 72. Angle B is 52. Angle C I just found, right? Sorry, I'm going to move it a bit. Angle C I just found that was 56 degrees. And now my sides. Side A I calculated, that's 20.28 centimeters. Side C I calculated, that's 1767. Side B was given to me, so I didn't need to calculate that. What do you call it when we solve for everything? All sides, all angles. We solved the triangle. Okay? We solved the triangle. You solved for all sides. There were 2 missing. and one unknown angle. One more thing, guys. This is before you work. I want you to realize this. This is the largest angle, right? Largest angle, right? 72 out of all three is the biggest. That one is across the longest side. Do you see that? That's how you check whether or not you got it right. Okay, largest angle, longest side. They're across from each other. What about the smallest angle? Smallest angle here is across the shortest side. I don't know how to do that one, so I'm just going to go smallest, right? And on this side, I'm just going to go and insert shortest. That's how you kind of check. You don't have to do this at the end. I just want to emphasize that that's what you're doing. Okay, this is how you calculate a missing side length. I want you to go to page 6, okay, and do the same thing we just did here. I want you to do that on page 6. I want to make sure you know how to use your calculator to know how to set it up, right? All of those things we need to make sure before I show you how to solve for a missing angle. So go with me to page 6, and I'll tell you what, okay? It says solve the following triangles. We're only going to focus on A for now. You might have some time later. If you're done A, sure, go ahead for B, but right now I just want you to focus on that. And so you're going to solve for all of these sides. Watch this. This is side X. It also wants that. Okay. You're going to solve for everything. So you're going to have to do a little bit of work on this side and then a little bit of work on the other side to make sure it fits. And I'll give you the answers right now so you know where you're at. Okay. So side Z, which is the first thing you'll probably find, is 624.91. And side X is 1315.01. And angle X is 33 degrees. So now you know. I will give you all the other ones later as well. But take some time, take 5, and make sure you know how to do A on your own. Okay? This is how to do an angle, how to solve for missing angles. So go with me to page 7. No matter what you're doing, go to 7 for now. Okay? Write down your notes, all right? That's part of the recipe. So this is how you solve an angle. You see the common error here? Never have an angle just on its own. It should be glued to sine. Okay? So watch this. You have a pair here. For now, all we know is sine law. I know that. But tomorrow, this is going to change. So this is an indication you have to use sine law. Okay? So I'm going to do this. Sine of 81 over 123.2. And on the other side, which angle should I solve for first? There's actually one that you can and one that you can't right now. The reasoning is, again, things have to be opposite each other. So because you have this side, right, that's the side that you're given, your only option is to solve for angle A. Would you agree with that? You have to agree, no choice. Okay, there we go. That's how you do it. That's how you do it. Mr. Dirksen, there's no X or side there. There's that annoying sign there. Yeah. For now, you treat that as your variable. So how do you cross multiply? You cross multiply this way and then you divide going down. That's how it's going to be a little different, but not by much. So watch this. Sine of A is 91.6 times sine of 81 divided by 123.2. This is going to have one extra line in it if you do it right. Next line is this. Ready? You want to drop that sign, correct? If you do that, what happens is you're going to take, do you remember this one? Sine inverse, do you remember that? Please tell me you do. If you don't, that's okay. What it does is inverse actually gives you an angle. So do this with me, okay? Type this in, 91.6 times sine of 81 divided by 123.2. And you get 0, so I'm going to put brackets like this, 0.7343, and it keeps going. I want you to use all decimals there. So what you need to do now, depending on your calculator, it's either shift, or it's second F, or it's, what else have I seen? Those are the two that come to mind right now. Shift, sine, and when I press equal now, it's going to take the inverse of whatever is on your screen. It takes the inverse of the answer. So that's your last fourth line. 47.25. What are we in? Meters? No, degrees. And you just found angle A. You had no choice but to solve for angle A. Okay. Can I tell you something on the notes here? Note. If this, I will make an underline like this. If that is, does not start with 0, sorry. I just thought of it now. Doesn't start with 0, you made a mistake. Okay. You're probably going to get math error or something like that. Math error or some kind of error message, if that's the case. So if you ask me on a test or a quiz, AC, I'll just say, check your work. Go back to your triangle. Are you maybe crisscrossing? Maybe the wires are crossed, right? Something is wrong there. So you got to watch out for that. It has to start with a 0. Okay. Sometimes there's a slight chance that I made a mistake when I set up the question. There's a chance of that as well, but most likely not. Okay, so we found that angle, no problem. Now it says calculate the length of side C, right? The length of side C. Well, Mr. Dirksen keeps on telling me to use the pair that I'm given, so I will do so. If I want side C, and remember, the side length is in the denominator, right? If I want the side length, what do I need up top here? Sine of angle C. Okay. I need angle C. Do I know angle C right now at this moment? Look up on your diagram. You don't know what it is. But you found this one right here, 47.25. Right? You found that one up there. So easy to find C, easy. So I will say, I will put an arrow to the side and just say need angle C, which is found by going minus 81, minus 47.25. Angle C is, off on my notes here, it is 51.75. This is important. I'm going to underline that. It's going to come in here. So one more line. You know how to do this part for sure. So you cross multiply this way and you divide by what is left. So C is 123.2 times sine of 51.75 divided by sine of 81 degrees. That should give you 97.96 meters. Which one is your longest side and largest angle? If you go back up, 81, and that's in that triangle, 81 is the largest angle and it has the longest side across from it. So we know we're doing something right. A is the smallest angle right now, and it has the shortest side across from it, right? You can tell 91.6 is the shortest out of all three. So there you have it. That's it. Hold it. I'll give you the answers. So we go to page 8 here. I want you to try it for tomorrow. There's actually very little you need for your study sheet. Very little. Like the formula for sine law is actually on their formula sheet. So page 8 with me. Here it is. Angle A is 2992. 2908. I will also post the key to this. If you're stuck, I will help you out. But I can only help you out if you are willing to put in the work, right? So don't come in cold turkey tomorrow. Don't try to wing it and come in cold turkey. That's all bird talk there. You see the numbers? Can you see them all? And I will give you page 6 as well. I'll just put it on here. Page 6 is right here. This is page 6 right here. I'm posting them online.